Hey Algebra Nation, welcome to section 2. Now in this section, we're going to be talking about everybody's favorite algebra topic, that means yours too, and that's equations. Alright, so we're going to be learning how to solve different equations, and we're going to have a good time doing it. So in this very first video, we're going to be looking at whether equations are true or false, okay, and what constitute a true or false equation. So I want you to think about the statement, 4 plus 5 is equal to 2 plus 7. Okay, that's a grammatically correct sentence, right? If this was English class, we would say, well, yeah, that is a well structured sentence. Now, in math, is this sentence true or false? So, what does that mean? That means, is 4 plus 5, which happens to be 9, actually equal to 2 plus 7, which also happens to be 9? Well, in math, yes, that is absolutely a true sentence. Okay, so we're going to say this sentence is true. Now, I want you to consider the statement 1 plus 3 is equal to 8 plus 6. The statement is also a grammatically correct sentence, right? So if this were English class, once again, we have our subject, we have our verb, and then we have our object, right? All there. All right. Well, guess what? Is this sentence true or false? Mathematically. Well, 1 plus 3, which is 4, is not going to be equal to 8 plus 6, which is 14, right? So no, that sentence is actually false. Okay? Now the previous statements are examples of what we call number sentences. A number sentence is a statement of equality between two numerical expressions, right? Between two numerical expressions, but remember this keyword here, statement of equality. So when you put the equal sign, that means the two things on left and right of it need to actually be equal to each other. Okay? So a number sentence is said to be true if both numerical expressions are what? If they are both equal. Okay? That's the main term here. It's the main word. Now, if both numerical expressions don't equal the same number, what do we have to say? We have to say that the number sentence is going to be not true, but false. Okay? And true and false statements are called truth values. All right? You gotta be telling the truth. Cool. So what we're going to do is we're going to do some practice. See if you guys can determine which of the following sentences are true or false. Justify your answer. Well, let's go to this first one. 13 plus 4 is equal to 7 plus 11. Well, let's see. 13 plus 4 would be equal to 17, whereas 7 plus 11 would be equal to 18. Is this going to be true? Nope. That one is false, right? 17 is not equal to 18, so the first one is false. All right. Next up. Here we have, looks like two fractions that we're adding. Is that going to be equal to these two decimals? So what we want to do is I'm going to go ahead and add the fractions on that side, right? So to do that, I'm going to have to multiply this one by 4 over 4 to have a common denominator of 8. So now I know that 4 over 4 times 1 half is going to be 4 over 8 plus 5 over 8. Now I can add these two fractions, right? Same denominator. Now, the math on this side, 1.4 minus 0.275, that's going to leave me with a 1.125. Okay? So let's go ahead and add our fractions now. Well, we know 4 over 8 plus 5 over 8 is going to be equal to 9 over 8. Is equal to 1.125. Well, guess what? 9 divided by 8 is exactly equal to 1.125, which means that 1.125 is equal to 1.125. Okay? So for this one, it checks out. We're going to have to go with this one being a true, whereas the first one was a false sentence. Okay? Awesome. Now it's your turn to determine these following truth values, right? So you're going to figure out whether the following number sentences are true or false. So I want you to pause the video, do it on your own, come back, we'll try it together. All right, let's see what you got. So we have this first sentence here. In parentheses, 83 times 401 times 638 is equal to 401 times 638 times 83. Okay, well, guess what? We learned about this before, right? We learned about commutative and associative property. Commutative property said what? It said that if you have the exact same numbers, which 401, 401, 83, 83, 638, 638, that you're multiplying by each other, okay? Doesn't matter of the order, right, that you put them in. So it doesn't matter that we move the order around here, as long as we're multiplying the same numbers. Associative property told us that it doesn't matter what numbers are in the parentheses, right, that you're associating with each other, even if you change that around, as long as all of these numbers, well, for associative, they would have to be in the same order. It's not because of the commutative. So both of these are being used in this case. Regardless, those two properties help us figure out that yes, the, these statements are going to be true. Okay, these are equal to each other, and if you multiply these out, you'll see that it's the same thing, right? Because they're the exact same numbers being multiplied out. Now, this is true. Why? Because of the commutative, and associative properties of what? Well, we are multiplying them, so it's the properties of multiplication. Cool? All right. Boom. Okay, so that's the reason why. Now, what about down here? Well, let's see. We have 6 plus 4, quantity squared, is equal to 6 squared plus 4 squared. Can we say that this is a true statement? Well, by the looks of it, you say, yeah, that's a pretty simple one, right? Be careful. Here, what do we have to do? We have to add in the numbers inside the parentheses first. So 6 plus 4 is 10, and then you square it. Well, what is 6 squared? 6 squared is 36. What is 4 squared? 4 squared is not the app, but it's actually equal to 16. Now, 10 squared is going to be 100. 36 plus 16 is equal to what? That's not equal to 100. It's equal to 52. Are these two equal? They are not. So this one is going to be false. Okay? So that one is true. This one is false. All right? Good job, guys, trying this one on your own. You guys knocked it out of the park. All right. Now, a number sentence is an example of an algebraic equation. All right? There goes that term. Now, what is an algebraic equation? It's a statement of equality between two expressions. Okay? Essentially saying two expressions are equal to each other. And sometimes we have to prove that, sometimes we don't. It's very clear and blatant to us, but those are algebraic equations. Now, algebraic equations can be number sentences, like we just saw, when both expressions contain only numbers. But often, very often, I want you to get used to it, you're going to see that they contain variables. Okay, these are going to be our letters. They're going to contain variables whose values have not been determined. Okay, so be very careful with that. We're going to see a lot of those. So consider the algebraic equation. 4 times x plus 2 is equal to 4x plus 8. Right here, that's our variable, right? We don't know the value of it exactly, but we know we're going to have to figure that out, right? Okay, so are the expressions on each side of the equal sign equivalent justify your answer? That's a good one. Well, if we use our distributive property, boom, boom, what can we see? 4 times x, 4x, 4 times 2 is going to be 8. So our distributive property tells us that, yes, these two are equivalent to each other. Okay, well, how do we justify that? Using the distributive property. Okay, so the distributive property tells us that these two are equal to each other. Okay, cool. Now, what does this tell you about the numbers we can substitute for x? Well, whatever number you substitute for x here is going to make the sentence true on that side as well, right? So I can put in 2 for x. 2 plus 2 is going to be 4 times 4 is going to be 8. 2 plus 2 is going to be 4 times 4 is going to be 16. Here, if I put in a 2 for x, 4 times 2 is 8. 8 plus 8 is 16. Okay, now you can play that game all day long. All we know is we can substitute any value for x, and this is going to be a true statement. Okay, so we can say substituting any number for x would make the sentence true. Okay, so keep that in mind. Now, let's go ahead and do a little bit more practice looking at these variables here. So I want you to consider the algebraic equation x plus 3 is equal to 9. Now, there's only one number that I can add 3 to get to 9. What value do you think that is that we can substitute for x to make it true? Well, there's only one number, right? So that number is going to be 6. 6 plus 3 is equal to 9. Okay, there's no two ways about it. 6 plus 3 is equal to 9. That's the only number we can substitute here for x to get that answer. All right? Now, how many values could we substitute for x and have a true number sentence? We just said, right? Only one. That's the only one. Like Kanye said in that song. Okay, now consider the algebraic equation. X plus 6 is equal to x plus 9. What values could be substituted for x to make it a true number sentence? Okay, now I want you to think about this. Let's say you and your friend, right, in the classroom, you guys are on two different sides of your desk, okay? So your desk is going to be the starting point. That's the equal sign. So you're both at x. Now, you take 6 steps forward, right? So plus 6. But your friend takes 9 steps forward. Are you ever going to meet up at the same point? No, right? Your friend took 9 steps, meaning your friend taking 3 more steps than you is always going to be ahead of you, right? It doesn't matter where you start because your friend's always taking more steps than you. So that tells me that there's no value you could put in for x that's going to make this true, right? It's going to make this a true number sentence. So there are none. There's no way I can substitute a value for x on both sides, right? So you and your friend have to start at the same point. Doesn't matter where it is. But if you take 6 steps and he takes 9, he's taking more than you every time. He's always going to be ahead of you. Okay? So there's no value we can substitute to make these two equal. Cool. So now I want you guys to go ahead and look at the following 3 here, and I want you to try those on your own. Okay? You guys got this. All right, let's see what you got. So d squared is equal to 4. Is true for what? So what value do we have to put in for d, for this variable, that would get d squared to equal 4? Well, I know that if I square the number 2, so d equals 2, I'm going to get 4, right? 2 squared is 4. Is that it? No, right? Because if I also squared a negative 2, negative 2 times negative 2 would still give me a positive 4. So negative 2 squared will still give me a 4. So d squared is going to be equal to 4 when d is equal to 2, or when d is equal to negative 2. Okay, so there's 2 possible values for d here. Now, what about when we have 2m is equal to m plus m? Well, check this out. 2m is equal to m plus m. What is m plus m? M plus m is 2m. These two values are the exact same, right? These are already equivalent, so it doesn't matter what I plug in for m. It's always going to be true, okay? So for any value of m, this statement is true. Cool? All right. Now, what about d plus 67 is equal to d plus 68? What is that true for? Once again, I want you to think about this. You're starting, you and your friend are at the same starting point, right? You guys are both d. You take 67 steps, your friend takes 68. What does that mean? That means that your friend is 1 step ahead of you. Doesn't matter where you start, your friend is always going to be a step ahead of you if he takes 1 more step than you do. Okay? So that's never going to be the same. D is never going to be equal. So it's true for what? It's going to be true for no value of D. Okay? There's no way we can make these two sentences equal because you're adding 67 to one and 68 to the other, right? It's not equivalent. All right. So now you know what time it is. All right, let's do this. You and your friend can both finish this one together. Cool? That's the beauty of it. So now, we are going to be, which of the following have the correct solution? Select all that apply. So we're going to be selecting all that apply. Here we have 2x plus 5 is equal to 19. We want to know if this is true when x is equal to 7. Okay, so we're being given the value of x. We have to see if it fits here. So I'm going to plug in 7 for x. So 2 times 7 plus 5. Well, 2 times 7 is 14. 14 plus 5 is equal to 19. 19 is equal to 19. We'll take that one. Next up, 3 plus x plus 2 minus x is equal to 16. That's going to be true when x is equal to 3. Well, let's make sure of it. So we have here 3 plus x, which is 3, plus 2 minus x, which is 3 once again. Well, let's verify this. 3 plus 3 is 6, plus 2 is 8, minus 3. 8 minus 3 is equal to 5. Last time I checked, 5 is not equal to 16. That one's not going to work. Here we have x plus 2 divided by 5 is equal to 2. That's true when x is equal to 8. Well, we're going to be the judge of that. So here we have 8 plus 2 over 5. 8 plus 2 is 10, divided by 5. What is 10 divided by 5? That's going to be equal to 2. Cool? So that works. Last time I checked, 2 is equal to 2. We're good with that. Now here we have 6 is equal to 2x minus 8 when x is equal to 7. Well, let's put x for 7. So we have 2 times 7 minus 8. 2 times 7 is 14. Minus 8 is equal to 6. 6 is equal to 6. That one checks out. Now finally, we have 14 is equal to 1/3 x plus 5 when x is equal to 18. So let's check. 1/3 times 18 plus 5. Well, what's 1/3 times 18? That's 18 over 3, right? Plus 5. 18 over 3 is equal to 6. 6 plus 5 is equal to 11. 11 is 3 shy of being equal to 14. So unfortunately, we came up short here. That one's also not equal. Okay? That's it for this one. All right? So you guys got this. Just make sure you keep practicing. You'll be able to figure out what values of a certain variable would create a true number sentence and when you have a true or false number sentence. Okay? Any questions? Go ahead and post them on the wall. If not, I'll see you guys later.